Welcome, everyone, to your Thursday evening stroll around your celestial neighborhood. I'm Irene Pease, your friendly neighborhood astronomer. Super excited to be here tonight, looking at the moon. I feel like I look at the moon a lot because it's on my calendar, but then I'm like, oh, that's not really the real moon. So I felt like the moon this week. So we're doing the Lunar Reconnaissance Orbiter for our mission of the month, and basically it's, just an excuse to look at the moon. So we'll be using same visuals as usual, Stellarium, which we'll pop over to a minute. You can find that at stellarium.org. OpenSpace, which you see in the background right now. We'll come back to this. You can find and download that for free at openspaceproject.com. And I'm also going to be using NASA Eyes tonight, which you can find at I believe it's nasaeyes.gov, and there's a couple different things you can either run online or download them for free. Thanks, NASA. So let's jump right in. Right over to the Stellarium. It's a beautiful evening in Brooklyn, as you can see, and it actually is kind of like this outside. I mean, so this is supposed to be our real time, so we're looking at now, which is always a fun thing. I can't see a mountain out my window, but I can see some bluish skies, and looking forward to seeing some darker skies in a little bit. So what's happening? Well, I thought, the moon. The moon's going to be happening this week. It's setting now, which makes tonight like a really great night to go observing, which I plan to do right after this. But over the next week, the moon is going to be doing that. So getting fuller and higher in the sky. It'll be out a bit during the day, so you could look for it during the day. That's really fun. And this week, this coming weekend, the next several days really are great for ISS passes. So if you have an ISS Finder app, I just use ISS Finder. It's a favorite. You can see when those are going to be. So there's actually one tonight. If we go back to now, 10:30, and these are all very localized, right? So if you're not in the New York City area, you'd want to get like your own times. Wow, I can't read my writing. I think that's 10:13. um Oops, maybe I should work on that penmanship thing. Is that it? Zarya, yeah, that's the one. So 10:13 tonight, tomorrow night, Friday has a couple passes. There's one at 9:30 and then one again at 11, just after 11, 11:03. There it goes. Zarya, wave to the space people on the space station. Saturday night, boom. We have a couple of them in New York City area again. The best ones are around 10:15. So these are kind of awesome. And actually, this one's going to be kind of coming a little bit closer. I think Sunday night is the really fun one here. Sunday night, that's the 16th, at around 9:30. It's going to be coming right up there past, there it goes, past the moon and the Mars and the ISS. So we have kind of a little constellation of some very local, some less local, and some not so local things just plodding along in the sky. So as the moon's getting higher, you'll also have the ISS like kind of passing by it. I also did a Monday 8:40 in New York is going to be the better one. That's a little bit earlier in the evening, but oh man, so bright. Here it comes. And again, like just kind of passing along. We'll almost kind of complete this trail of planets for a moment. So you notice we have all the planets out, or so many planets, 3 planets out in the west sky after sunset. So it's going to be kind of a fun May with all those out there. Mercury and Venus kind of catching up to Mars. But yeah, so this week I would say focus on the moon, catch the ISS if you're in the New York City area. There's going to be a whole bunch of really great passes. I also wanted to take a look at some constellations because, I'm did like a spring skies thing, but I also want to make sure we cover our bases for summer, so we're all ready for the summer skies and all of those constellations. So we'll go ahead and move the ISS out of there for nows, and block off some constellations. So it's still spring, right? So we still have kind of Leo, Virgo up there, but just kind of reviewing. I think I did a little review last week. We're just going to re-highlight some of these and maybe focus on them in the coming weeks. So from the Big Dipper, which is like way overhead, that's actually going to be behind you if you're facing south. But if you find the Big Dipper, again, you're arcing to Arcturus, which is in the ice cream cone of Boötes. There's a label, booties, some people call it. I call it Boötes. So you arc to Arcturus, that really bright star. It'll be kind of a reddish, orangish, yeah, more orange-yellow hue. Red, I'm kind of kidding myself telling me anything's red up here, but kind of a orange-yellow hue. So arc to Arcturus, and then speed on to Spica. Spica is this not quite as bright as Arcturus, but it's a kind of a blue-white star, all twinkly towards the southern horizon if you're, mid-north latitudes. And then you curve to Corvus, which is a little bit fainter, but I mentioned I did see that in Brooklyn. If I can see it from Brooklyn, you can probably see it from anywhere. And then we're going to take that one step further, and we see this kind of stringy constellation, Hydra. So Hydra is actually the largest constellation in the sky by area. So if we actually look at our constellation boundaries, Hydra takes up an awful lot of real estate, more than any other. Actually, the next most greatest area constellation is Virgo. So we have these two like large, spacious constellations in the sky. And I kind of like this time of year where Hydra is just kind of like hanging out along the horizon. Like it's just, as it starts to set, it's just like snaking along the horizon like a Hydra should. So there's this kind of little curve of stars that's going to be a little bit harder to see as the moon is coming up through there this week. So maybe try to find that earlier in the week, like over the weekend. Little curve of stars, not a whole lot of bright stars. Alpha Hydra is a little bit bright. If you can see Corvus, we'll talk about Crater next time. There's another kind of bright-ish star. But if you get out to a dark site, see if you can pick out some of these stars, especially like the head of Hydra, and then kind of like connect the dots with whatever stars you see just a bit above the horizon there. So that's kind of a challenge. If you can do the ice cream cone, speed on to Spica, curve to Corvus, you can do all that, then start looking for these stars of Hydra. And we'll talk a little bit more about the constellations that are kind of nestled in the little crooks and crannies of Hydra. That's a goal for the next few weeks. So yeah, so that's our skies. And and now we can pop back over. We're actually not going to go to OpenSpace just yet, but as promised, I want to check out NASA's Eyes on the Skies. So Eyes on the Skies lets you kind of poke around, different data sets. This is Eyes on the solar system. So a lot of solar system objects, both the planetary bodies, all the worlds that we've explored in our solar system. And one of my favorite features, of course, is that we get to look at all of these probes, all the orbiters and landers, and some of these things that we've sent out on various missions. So this is already kind of centered on our star tonight, the Lunar Reconnaissance Orbiter, LRO. Yeah. So just a quick tour, I guess, of LRO before we jump in. So, oh my goodness, yeah, you can see all the fun things in the background. Oh, yeah, all the missions we need to do. So LRO has this, it's been up there for a while, right? So it was launched back in 2009, June 2009. The mission actually began in September 2009, and it started with just a one-year mission, which was extended for another 2-year mission, and then they just kept extending it because it's awesome. LRO has like a whole mess of instrumentation I think I'm gonna just kind of speed through time a little bit so we can get maybe a little more light on the subject. I don't know if we're going into the dark before we get more light again. That looks kind of light. Yeah. All right. So this big old solar panel, right? So the solar panel is hooked up to, a lithium ion battery. So we're looking at the back side of the solar panel at this point. But just for reference, to give you an idea of the size of this thing, the solar panel, I wrote it down somewhere, is about 4.25 by 3.25 meters, right? So it's big. It's not tiny. It's not just a little box. It's several meters, and the box, the kind of instrumentation package, is a bit bigger, or sorry, is a bit smaller than the solar panel there, so you can see. But yeah, so that panel, about 4.25 meters by 3.2 meters. So yeah, a little bit smaller than my apartment, but not by a lot. So LRO has a whole mess of instrumentation, basically lots and lots of, yeah, a couple of cameras, and it also has some really great acronyms that go with it, which is one of my favorite things. So let's see if I can pick these out here. So there's a mini infrared, basically a high resolution radar, which is kind of this oblong thing, this kind of box along the bottom as we're looking at it, kind of the bottom right. So that thing sticking off, that's your radar, which is pretty awesome. That's called mini RF antenna. And then if we kind of slide up, the box on top, you can see kind of two circles on the left, and then like the cylinder with a circle on the right. So on the right, you have LOLA. So that's your lunar orbital laser altimeter. So we get really great height maps from LOLA, and then the other two are just LRO, just cameras. The LRO is just LRO cameras, so more more data collectors. One of the fun things that's on here is off to the it's off to the right. This stuff kind of hanging out off to the side over here on the right side, sticking off the box towards the upper right. That's a crater. So that's a fun acronym. So the crater is the cosmic ray telescope for the effects of radiation. So detecting different types of radiation. So we have infrared and UV detectors. We have radiation detectors. We have this other blob way off on the left, that big thing that's sticking off kind of on the left side, that left corner. That's LEND. That's the I just had it, the Lunar Exploration Neutron Detector. So it's detecting neutrons as well as other particles. LAMP is the UV, that's the Lyman Alpha Mapping Project. So it has some really cute acronyms, some very thorough suite of instruments for looking at various wavelengths and also detecting particles and also detecting like really being able to map out the height. So one of the purposes of LRO was to be able to map the moon in more detail in case, we want to go back there, because, we kind of wanted to go back there. We still kind of do. So we haven't quite been back yet, but we'll get there. It has been used to map the moon basically in 10 times the resolution of any previous missions that were sent up there. So even back in the day of the Apollo missions, in order to get really high resolution maps of the landing sites for Apollo, they kind of did this thing where they just basically, it's like the modern version of like they threw a GoPro at it and just crashed it in and like recorded, like just watched and saw what they could see. So like literally they just like had these probes that had like a whole mess of TV cameras from like the 60s like mounted in all directions, and they just like threw the thing at the moon, and as it approached like the site, like they just watched the footage of that. So a little bit more high tech here with LRO. So it's orbiting pretty close. It started off in a more highly eccentric orbit, but now it's down at around 50 kilometers of altitude. So it's pretty close in. Um, and I managed to not actually get the resolution, but it's good. I think there's some areas where it's less than a meter resolution, so pretty amazing. And I just wanted to stop by a couple of the areas um, that we've been able to see. So I think I've talked about some of this lunar stuff a bit on previous um, tours. One of the fun things, and we're just going to kind of, I guess we'll just kind of zoom in towards one of the regions. Um, One of the fun things that it found were these things that are called skylights. So I think I've mentioned those in a previous mission. So skylights are kind of like these collapsed regions inside of like what would have been old lava tubes. Um, but they're kind of skylights because they're deep enough and dark enough that we can't necessarily see down in there. So if you think of like a collapsed lava tube with like a hole just in the top of it where it's been collapsed, um, that would be like a like a skylight in your window in your bathroom or something. So that's kind of what these are on the moon. So LRO was able to image a bunch of those. Um, Pretty neat, kind of neat little features. They just look like little black spots, but like looking in closer, it's like that's not a crater. That's like a that's like a different kind of feature. It did a really nice job of actually mapping out the poles. So you can see there's like some artifacts that we get from the data set. So it's in a polar orbit. It doesn't go around the equator, but it goes around the pole, and it's close enough that it orbits the moon every 2 hours. So the moon kind of rotates underneath it. So as the moon rotates on its axis, LRO gets a view of all of it. So it was actually the first mission to completely do thermal mapping of another world through its entire day and through its entire season. Like, so basically, like a whole season, like a whole day, which is, like 27 days, 27 Earth days for like one day on the moon. So we actually do have really great maps. I know doesn't look awesome right now because it's still loading in, but really fantastic maps of the poles. So this is a polar region. We just kind of zoomed in here to focus on Hermite Crater, which I think, yep, that's the one. So this crater that's kind of in the center here. So again, it actually makes, kind of thermal scans in addition to imaging, in addition to the altitudes. And so in this crater is where one of the coldest places in the solar system has been recorded. So there's other worlds in our solar system that are on average colder, but since we're able to like basically map the temperature of the moon, this is actually the as far as actually directly recording a temperature at a location on other worlds. This rang in at under 30 kelvins. So near the poles especially, there's some places that like stick up. Like I think the edge of this crater up here, you have continuous sunlight as the moon rotates. And then there's other regions where you're going to have perpetual darkness. So those can get very, very cold. And then the perpetual sunlight places, that's where you might want to put a base. So you can put like big solar panels up there. So you have continuous sunlight, continuous power, because that's going to be handy. So yeah, so finding cold spots, mapping oh gosh, that's so beautiful. Mapping the poles. Actually, if we flip around, I want to maybe take a quick look at the South Pole, just because it's amazing. And I have a picture for that. And I need to double check which data set this actually is as we move down there. Because we have a couple different layers. I want to actually turn on just the Lola layer. So this will take a few minutes to load in. Hopefully it won't take too long to load in with all the other fun things I'm running to turn off some other stuff. Get a little bit more memory going here. Yeah, so you can see, ooh, bit by bit loading in. So again, OpenSpace is using all real data, and a lot of it's very high resolution. So like NASA Eye is also real data in there, but as you can see, like as we were flying over the moon, it's not like super high resolution. So this is like the super high resolution from Lola, from our Lunar Orbiter laser altimeter. So we have it's not like pretty pictures, but you have like a really really solid height map. So coming down around here to the southern tip, woo, and I might just bring up a picture while that loads in. The South Pole is pretty awesome. It's kind of fun because like the South Pole on the moon has is a lot of the craters in here are named after like South Pole explorers from Earth. So like that, I'm pretty sure that this one in here as it loads in is Shackleton, and there's Amundsen and Scott and all these other fun. I think I want to rotate around like this. There's this kind of funky one. I can always remember this one that looks like all like cracked and really weird, like something really odd is happening. I think that's Schrodinger, like some quantum thing going on there. But I wanted to bring up, ooh, yeah, this real quick. Like, so this is just to kind of give you an idea of like the variety of data that we're getting from LRO. These are views of the lunar South Pole, as it says, but with the different instruments. So just with sunlight, with the infrared, with the UV. Again, that UV, that's the, is that the lamp? Yeah, so that's the lamp. The infrared is just DLRE. The radar, that's the mini RF. You have your elevation, and the neutron detectors, the lens. So all these different instruments that give us kind of different views that tell us information about, you know, the landscape, the altitude, where there might be water, right? So with different particles, they're like looking for stuff we can use to make water because we want that for a long-term base. That's important for having things to breathe, having fuel, having water to drink, and do other things that human beings and other living things need water for. So yeah, so there we are, our South Pole in all its glory. I was gonna stop by a different region, but I think, pretty sure it's Schrodinger. Actually is pretty amazing. So a lot of the craters, there's a couple really cool craters like just past the edge between the light side and not the light side, the near side and far side. So kind of past that edge that we can see. And they have these huge mountains in the centers of them. So like that splash point. So when something really big hit the moon in the distant past and made a crater, and you get that little blip, that kind of mountain rising up in the center. So instead of like having a mountain rise up in the center, this is like kind of like a ring, like a chain in here. So I just wanted to come into like at least one of these kind of sites, just to get an idea of the resolution for the altitude. So if we can drop down in here a little bit. Again, it takes a few moments to load in because I don't have super duper high speed. But this is the kind of fun thing you can do with like this 3D data. Oh, there goes the Earth. Goodbye, Earth. Is like really like drop in onto these surfaces and kind of like move around in 3 dimensions. So it's not just like flat, but again, there's the data's been stitched together. So you have your map, and then you also have your height maps in here, which I don't know how that happens, but I'm just glad it does. So that's that's a thing that some of the open space software engineers have been doing and working on projects for us, which is awesome. So yeah, so kind of amazing just to be able to explore the surface. And again, this is basically all LRO data. So without LRO, we wouldn't have nearly this resolution, and it's still not even like completely loaded in. But I think you get the idea of like how fun that can be. The is a slightly more practical thing. Again, it has been helping to scout out sites for other missions. So we have sent a few other things to the moon in the last few decades. China sent a few missions to the moon. It actually landed on the far side. It sent its China sent their own orbiter up there to kind of preview that space, because we can't see it from Earth. So even with like really amazing telescopes, you're not going to be able to get a view of that part of the moon where they landed. So LRO was able to like actually pick out the landing site of Chang'e 4, which again is on the far side. But the other thing that I wanted to kind of toy with in here, if I can get oriented halfway, unlikely, is yeah, I'm gonna put like other colors back on. Yeah, is I want to go ahead and take a look at the Apollo 11 site. So for all the various landing sites on the moon, you know, some people are like, oh, it didn't really happen. I can't see it. Da, da, da. Why can't you see the flag? It's like, well, you can see the flag if you look close enough. But we don't have big enough telescopes on Earth to see that. But we do have we do have LRO. So there's actually LRO took several images of the Apollo 11 site. If I just go ahead and focus on that. Yeah, target. It's pretty close. And it took it at different times of day, like different lunar days, that is. So if we flip through here, you can see exactly where it is. And I think there might also be like a little module just as a marker. So we zoom way in here. We don't have to wait for everything to load because these are just kind of flat images in here. But these are LRO images. Yeah, so there we can see there's kind of a little LEM. I can turn that off. Yeah, but we can see basically the shadow of the LEM as it changes. So like you can see shadows within the craters here, but here we can see like the shadow of the LEM casting that along the surface. So if we flip through, there's another day, a different shadow. So you can see the shadows like get longer and shorter, different times of day. Not another day, sorry, another pass on the moon. So a different time of day. So there it's like, you know, closer to high noon, much shorter shadow. So yeah, so LRO was able to pick out the vehicles that were left behind. It was able to actually resolve the tracks, the human tracks, so little footsteps. So the track, I think Armstrong went over to this crater and back. And even the tracks of the rover, so 15, 16, 17 Apollo missions brought cars, because can't get more American than that. But yeah, so those also show up. So a lot of pretty amazing stuff that we've gotten from LRO. And again, to think that it was launched, you know, over 10 years ago. So it's like 11, going to be 12 years old this summer. 12 years of mission this September. So pretty incredible mission. the little, I would like to call it like the little orbiter that could. These days, everything happening on Mars, which is obviously very exciting. We tend to hear more about there's also a MRO, there's the Mars Reconnaissance Orbiter. But the LRO, we also have one orbiting the moon and collecting a bunch of really great data that's going to help us to pick out new sites and figure out where there's water and where we might want to set up a base for when we go back there. So now that I'm really excited about the moon, I'm going to go look at whatever's still up in the sky. Not the moon, I guess, but other fun things. Maybe some galaxies that are out there. See if I can find Hydra. But thank you for tuning in. Thank you for joining me. Again, I'm Irene Pease, your friendly neighborhood astronomer. Visuals we've been using tonight, Stellarium, which you can find at stellarium.org, and OpenSpace, which you can find at openspaceproject.com. And we also use NASA Eyes on the solar system, which you can find, pretty sure it's nasaeyes.gov. I'll be sure to put that in the description. Next week, I'm super excited. I don't know if anyone knows, I believe Towel Day is coming up. So if you don't know what Towel Day is, look it up. We're gonna be kind of nerding out with Towel Day, and I'm excited to check out the Big Bang Burger Bar and maybe even the restaurant at the end of the universe and other fun things around a Hitchhiker's Galaxy. So that should be fun. In the meantime, everyone stay safe out there, clear skies, and if you haven't, go get vaccinated.